Okay, so let's go back to the power series about a. So you represent it like this: C0, C1 x minus a, C2 x minus a squared. Let me write one more: C3 x minus a cubed, and so on. Okay. Now there's actually a relationship between these coefficients and the derivative of this given function. So here's a relationship. Let's see what happens if we actually plug in a in here into the function. Do you see that all the terms with x minus a will turn into 0 except for c0? So do you see that f at a is equal to the first term? Now let's differentiate this. Okay, let's differentiate this, and we get c1 plus c2 times by 2 x minus a, 3c3 x minus a squared, and so on. And let's plug in 0 in there. So let's plug in a in there. And you see that every term will turn into 0 except for c1. Okay, except for c1. Okay, let's do one more. This time it will become 2c2, and then you get a 3 times 2 c3 x minus a, right? The next one would have been 4 times 3 times 2 c4 x minus a to the power of 2. So in here, if you actually plug in, right, if you plug in a, you get 2 times c2. Okay, if you continue this pattern, the third derivative, if you plug in a, you're going to get 3 factorial, 3 times 2 c3. The fourth one, right, 4 factorial c c4. So in other words, right, cn will be this, right, the nth derivative of the function at a divide by n factorial. Okay, that's the relationship between the coefficients of the power series and the derivative. So our power series now can be rewritten as, or the cn can be replaced with this. Right, so, well, it's too bright. Let's go back to black. Okay, so yeah, it's f, the nth derivative at a over n factorial of x minus a to the power of n. Okay, and this right here we call, right, this is the Taylor series. Okay, we call this the Taylor series. Okay, and if you set a to be 0, okay, if a is equal to 0, this formula simplifies. Right, this infinite sum simplifies to 0 n factorial, and this becomes just x to the power of n. And this one right here is called the Maclaurin series. Okay, so it's essentially power series with a relationship. We found the relationship between the coefficients with the derivatives. So let's do some examples which we can use this to our advantage.